Hi guys, and welcome to another Strelok C++ tutorial. I was just watching the Mandelbrot set, which is actually really cool, and the cool thing about it is that some guy actually printed out the Mandelbrot set in 2.5 lines in Perl code, and that's really astonishing to me because I know how tough Perl can be, even though I've never programmed in it. But yeah, so actually I'll be right back. And I'm back. So today's tutorial focuses on pointers. Well, right, pointers. So a pointer can be denoted. This is the easiest way to think of a pointer. Well, maybe not the easiest, but the pointer is this thing. It's an arrow pretty much that points to an object, and this can be an object, A or X. So a pointer to the object is basically the same thing as the object itself, because it points to an object. So well, let's start writing our examples, and then we'll look at what it actually means. So include iostream and include conio.h for now. The standard namespace. Ooh, that's bad. Oh well, so many distractions. So int. Oh crap. Okay, sorry again. That was the MIRC chat, and yeah. So we declared our int main, and let's see, today's lesson is going to be about pointers. So as again, I have my closing statements. Okay, so let's fool around with pointers. You remember from lesson, what was it? I forget. How I said that this was a unary operator, unary dereferencing operator. Well, this is going to come in handy to know. But for now, let's declare pointer. So a pointer is declared similarly to a normal integer in p number. So first of all, notice the star but before the pointer. Some people prefer to write it this way, and their logic is well, p number is an integer pointer, so it points to an integer. And some people write it like this, and their logic is that the pointer p number points to an integer. And both of these are fine, and you can write either one, so you can write this or you can write this. I personally prefer to write it this way because if you write the integer pointer this way, and then you have p number 2. The thing is, this p number will be an integer pointer, but p number 2 will not be. So if you write this notation, you might be confused. P number 2 is actually an integer, because this star refers only to the first number. So you could write it this way, and then both of them are going to be pointers, I think. And so that's why I prefer to write integer pointer p number, because it actually shows that this refers to here. But once again, it's your choice, so we'll declare a pointer p number. And now we'll declare an integer x, which is 5. So, so far, pointer p number does not have any, it points to nothing. It's a stray pointer. It's lost. So let's find it a target. So p number is equal to this is the reference operator, and it shows us the place in memory where this is located. So the reference of x. So p number is, we assign the value of x to p number, actually the place where x is to p number, and now p number points to x. So now we say cout p number is and now we put, this is the dereferencing operator, so p number cout x is x. Oops, here we go. Okay, so let's compile and run this, and I'll save it as pointers. P number is 5 and x is 5, so they're the same thing pretty much, because I assigned p number to the place of x. And let's just put an end-l here, because to clear things up and to make it more aesthetically pleasing. So p number and x are now the same thing. So now let's say plus plus x. So we incremented x, and they both incremented. Why? Because p number holds the same memory location. Actually, it points to the same memory location as x. So whatever we do, it's like, imagine, x being a box. So x is here, and p number is actually pointing into the box. So whatever is inside the box is the value of p number and x. It's actually the value of both. So because we by doing this, it's kind of like we drew this arrow here. So that's pretty cool. So right, and what if we do plus plus p number? Sorry, plus plus p number. It will actually do the same thing. P number is 6 and x is 6. But when you're trying to refer to x, actually, you have to use this dereferencing operator. So because p number was assigned to the reference of x, this is the reference of x. So therefore, if you just cout p number, you'll get the reference of x, which is probably the memory location. So you have to use the dereferencing operator to actually get the value of x. So if you increment the memory location of p number, well, guess what happens? P number becomes some random number because you went to the next box over. So it's basically like this was your pointer, right? Okay, so this was your pointer, this was your box, and now this was x, and this was the original statement, and when you incremented p number, you made it look like this. So you see now p number points to this box, which has some random numbers in it.